So in particular, if we look at functions here, what's interesting is that in a way, there's this basis in math. So this is one piece. If we say a function here at the center of the universe, and what are the things that you can do with a function? Well, one of them is that's a very interesting one, is just math in general, right? So, if you wanted to do some kind of a x x to the 1, right, or x squared, or or do calculus, do derivatives, whatever it is you want to do, there's a direct relationship with a function in Python and mathematical calculations. And that's one use case of functions. Another one is the ability to do parallel computing. So distributed computing is a use case where you'll see functions used all the time. And in particular, you'll see this with the multiprocessing module in Python. There's the ability to map a function to a process, or in the case of asynchronous code. So we can say, maybe put a tab here that says multiprocessing module is one place you can use it. Also, in terms of async code as well. So if you're going to do a network-based concurrency, that's a great place to use a function. Another one is decorators. So in Python, in particular, you'll see this a lot, that people will use decorators to map a function and engulf it and then do something else with it. You'll also see functions in data science. So in particular with pandas, you'll see people use functions. And because the thing you're dealing with is a data frame, there really is no other way to apply something to a row other than to apply a function where it processes things step by step. Another place that you see it is in GPU programming. Or we could call this high performance computing. You'll see that Python has a library called Numba, and Numba allows you to easily write code that talks to a GPU. It also does high performance computing as well, in terms of making the LLVM just-in-time compiler work with Python code. Also, command line tools. So you can build functions to build command line tools. You literally map a function to a command line tool, and then web services is another example. So if you think about functions in general, they're actually the cleanest way to map a piece of logic to something else in Python. And it's interesting because there was a period of time where object-oriented programming, in a way, is almost in we'll call this OO. They're kind of in conflict a little bit, in that an object-oriented programming approach has advantages in that you can create abstractions, but in a way, it's not the direct one-to-one mapping that a function is. A function solves a very particular problem, and object-oriented programming solves a different kind of problem, which is code reuse. So I think mastering functions in general is a very useful thing to think about. And really, with the cloud computing, a lot of the things that we're doing are more focused on functions and more focused on microservices. And so I think it's a really good thing to have in mind when you're thinking about, why should I use a function, and what's the point of a function. It really is the simplest way to solve a problem. So in order to get started here, let me share a repo called function bike rider. Do this, and in particular, what I'm going to do is go through a few examples here of this particular repo. So inside of this repo, I have a makefile here, which is something I typically do, is I put inside of here the commands to install and to test something, to format it, to lint it. And then I also have my command line tool. And so here's a command line tool here, or here's a piece of logic that later I can turn into command line tool. And if I go to hello CLI, what I do is I actually import that piece of logic and then build a command line tool with it. So let's go ahead and play around with this. So the first thing I'm going to do is use something called code spaces right here. And this is a new feature that I don't know when they're going to release it publicly, hopefully this week through GitHub Universe. But what's nice about code spaces is I can go to this repo here and just open it up and start, writing code directly against it. So that's what I'm going to do. And from here, I've already got a virtual environment created, so I'll make this a little bit bigger, and then I'll source this virtual environment. So I'll say source // function bike rider. And the virtual environment is helpful because it makes sure that I have everything set up in a way that I'm not going to get weird conflicts. And if we look at this makefile here, you can see that I can run this make install command, and it will look inside of this requirements file and install all those packages. So let's go ahead and do that just to double check that everything's running here. There we go. Great. So now that I've got this make install set up here, the next thing that I can do is take a look at this, again, this hello world function here. So notice that this is a really simple Marco Polo function that takes the word Marco and or the function Marco and accepts a parameter called name. And inside I look for that particular parameter and I say, if the name equals Marco, return back Polo, otherwise return back no. So if I go ahead and I run this, I can actually first run this using IPython. I like to test out functions first with IPython. I think it's a great way to explore code and interact with things. So here's an example. If I just say from hello, import Marco, now I can actually test this out. So I can say Marco and put in some kind of a name, and we'll say Bob, and it returns back no. But if I go through and I say Marco and I put in Marco, it should return back Polo. There you go, Polo. So I think this is a great way to build out the function. So again, if you're thinking about, going back to this diagram here, that literally anything useful in programming you can do with a function. I think it's a great way to think about solving problems, and it's almost like a paradigm shift, which is instead of focusing on building tons and tons and tons of code, if you just say, what problem am I solving? Am I doing GPU programming? Okay, great, let's do that. Am I doing command line tools? Okay, great, let's do that. Am I building web apps? Okay, great, let's do that. Or am I doing data science with pandas? Let's do that. And if you focus on that very specific logic, then you can do things like this. You can build a very small function and then play around with it first by building a script and then importing that script into IPython. In my opinion, this is probably 10 times faster to write code this way. So now that we know the logic, right, there's a couple things that I can do. One, if I wanted to, I can go back to writing a test now for this piece of code, right? So we know it works from the terminal. So what I can do here is I can say from hello, import Marco, and I write a test here that says assert the word Polo is equal to Marco. And if I wanted to, I could also say, I could write another test and I could actually write what the logic is for when this code has the negative case as well. So if I go here, I could actually go like this, whoops, and I could take the word no here, and I could go back to this test and add another test case. So I can say def test not Marco, and let's go ahead and do that. And we can say assert, and I can do this. I can say no is equal to Marco, and we know that Bob should return that. Now, if I want to, I can go through here and say make test, and the make test command here, all this does is run the test file with PyTest. So we'll go through here and we'll say make test. There we go. And notice now that what's nice about the way this is run is that I not only get to see that the positive case worked, but I also got to test the negative case as well, which is pretty useful. And then also there's a command here that shows me this another function later that we'll get into. So what I can do to further, kind of get this initial part of the project working is also add a test coverage. And you notice here that there's a library called pytestcov, and I can go through here and inside of my makefile, actually, we can say dash coverage equals, and then put in each of these files that I want to test. I can say hello to start with. Let's go ahead and try that. And we'll say make test. And notice that you can see that hello is got 100% test coverage. And I also could test the command line tool, which we'll get into in a second. We'll say coverage is equal to hello CLI. And then if I run this again, you can see that now it shows that that's got 89% test coverage. So now that we have got not only this little function tested and we're able to interact with it, we can start to build out and map a command line tool. So let's go to this hello CLI command line tool here and notice how straightforward it really is. What I would recommend is put a shebang line in at the beginning. So this shebang line is a pound exclamation point user bin env python. So what this means is that I don't have to type the word Python to actually run this command line tool. As long as the file is executable, it'll look for the Python that's in my environment and run the command line tool. Now, one gotcha here with this shebang line is that if you're not using a virtual environment or a Docker container, then there could be some issues that could crop up with this. But in general, I think this is a decent approach. The next thing I do is I use this library called Cli. And what all Cli does is it maps a command here, and it gives us the ability to put options inside. So notice that all I need to do to use this other file here, this hello file, is I import it. Let's just move this next here. I import it, and then I add in an option right here that says -- name. And we know that this is a very simple function that all it does is take one keyword parameter here. And then I also put in this fancy print statement here that in Cli you can actually style the results, and you can specify the background or the foreground, which is a nice little feature. And then at the bottom, I just add the function, right, which is called Marco. So let's go ahead and run that. In order to run that again, I could do this, just guarantee that it's executable. So chmod plus X would be the way to do that. And I do this. I say hello CLI. Now that I've got that set up, I can do / hello CLI, and then I could run help to see what the help menu will be able to give me. There we go. So it shows us that this thing accepts an option that says name, and if I want to then test this out, I can just do the up arrow here and do name, and we can put in the word Marco like this. And there we go. We can see that the word polo appears. So it's a little bit hard to read with the blue background. So maybe we can swap it. So we can just do this. We can say, let's make this white background, and then maybe we'll make the foreground blue. Try that. Let's go ahead and run this. It's a little bit better, but still the background white doesn't really fit. How about what about yellow? And then maybe the foreground can be white. Let's try that. Or red, maybe. Yellow and red seems pretty good. Let's go ahead and try that. And there we go. Okay, so it's a little bit better. We can see that this command is running our Polo. I also can change this to test out a different use case, right? We know that this should return no. There we go, and it returns no. So there's a lot to like about this workflow, and if we look through what that workflow is, I can actually describe it in this README file. So what I can do is maybe say here, this is a building a command line tool workflow. So building a CLI workflow. So how would you do it? So step one is write a function. Or actually, first create scaffolding for your project like I did. Scaffolding in Python, right? So that would be, like a makefile, virtual environment, that kind of stuff. Step two, write a function in a script file, right? And then step three would be to test it out in IPython. Step four would be to then, once you know it works, write a test using PyTest and test, file like that. And then step five, write a command line tool, and then six, test all of it using the write a click command line tool, and then test all of it using the click test runner. There we go. So really, there's these 6 steps, which, in my opinion, really allow you to build things very, very quickly if you follow this pattern. And instead of, again, going into just writing a bunch of code, what's nice about this is that it's building these safety mechanisms that protect you from making mistakes. So what I'll do here next is go back to this test file here and notice that I have this test called test search, and we can probably rename this. That's not a great name for it. We'll call this test CLI. And notice what I do is I say from click.testing, they have their own test runner here. And this test runner, what's nice about it is that it allows me to invoke it with the exact way I would call it from the command line. And so notice here it says runner invoke, call Marco, -- name is equal to Bob. Now I could actually, if I wanted to, go really into detail and test even more stuff. Let's write another test. So one of the things that we notice here, that this is only testing the positive. So we'll call this, or the negative. So we'll say test not Marco there. And we also could verify that we could write a positive test as well. So we can say test Marco CLI, and we'll go ahead and put Marco. And notice that in this case, this would not be the output. Let's go ahead and run it because it's a mistake, and just we'll see what happens. So if I go through here and I say make test, notice that there's a failure here, and in particular, the failure that occurs is that it says that the assertion error is no does not appear. In fact, Polo appears, and so now we've got an assertion error, and that's a great aspect of the way this testing framework works. Is it's really easy to go, I made a mistake. How do I fix this mistake? Well, we know that in fact that's not what appears we know that polo appears. So we can go ahead and change that, and it should exit cleanly, right? It should be a 0 exit status. And let's go ahead and run this. We'll say make test, and there we go. We've added another test case here. So we've got both positive and negative test cases for the function, and then positive and negative test cases for the command line tool. Now, maybe some of this is overkill because you could probably get away with just writing these, but it's really depends on the use case that you're using when you're building the command line tool. But let's actually expand this a little bit and make it a little bit fancier. So and test more. So if I go back to this hello CLI here, the other thing that we can do is I can actually look for add a little more logic and do different things depending on what logic is in place. So if I say if results is not Marco, then what I can do is say, maybe take this result and do something slightly different, right? So maybe what I could do is I could say, we'll just only do the background red, and we'll have no foreground color. Let's try that. And then otherwise, let's try this use case. So if I go through here and I say make test, and then I go and I say Bob, notice that I'll need to exit out of here. So what I can do is I can say import sys, and then I can say sys.exit 0, for example, right? So I could go through here and just say, go ahead and exit if I wanted to, if this is in fact the case. Now that's one way to do it. Another way to do it as well could be to just do a return. So we could just say, return true, right? And we could exit. So let's try both approaches. So first one, if I go through here, now we exit properly. If I do the other one, that's another approach that I can use. I could also just do a sys exit and return it. Really, there's not necessarily one advantage to doing this. It's really up to you how you want to exit it out. Let's just leave the sys.exit in here for now. And then notice with this one as well, maybe instead all I want to do is do the background, and we'll say green. So we know that it gives us a signal that our command line tool, when it's doing what I expect it to do, it returns back the right thing. So if I go through here and I say Marco, we can see that it returns back polo. That should be background if results. Not sure why it's turning back. It's kind of strange that it's not giving me the right color, but basically the this is going to be, we can also do an else statement to kind of clean this up, and we should be able to see a background as well. You don't need an else statement because it's implicit that in this case it will say that if in this particular case the result is not Marco, it'll do an exit. Otherwise, it'll do the other test case, right? So let's go ahead and reload this window. Yeah, so when you reload one of these windows here, it's important to make sure that you actually go through here and resource the virtual environment. So if I go through here, this should double check I do that. There we go. We got Bob, Marco. Yeah, not sure there must be some kind of weird bug in here why the background's not changing. It's really not that big of a deal. But if I go back here and I say make test here, we can go back and double check that everything still works. So it just gives us a little bit more flexibility if we want to do different things based on, actually what I can do real quick to debug this is, why don't I just do this? I just say, let's actually just say, comment this out and say click.echo result, just like that. Let's make it simple. Yeah, weird that it's sticking. It really wants to give us that particular result, which is very strange. That's a very weird behavior. There might be something subtle going on with, you know, that once you set this in code, we discovered a bug. But in a nutshell, the core concept here is that we can test different use cases in this function. So now that I've got that working, I'm going to do a git status, and I'm going to add in this make file. I'm going to add in this readme file, and then I'm going to add in this hello CLI, and then add in this test hello, and then I'm going to commit it. So adding fully tested application. There we go. Perfect. And one of the things that we can do, because it's in GitHub here, is I can actually go back to GitHub and look at GitHub Actions. So let's go ahead and look at this function bike rider here and look at GitHub Actions. And I'll walk through how we could also use that to test our code. So notice that this queues up a job here. And in particular, what it does is it goes through and runs the test. It just runs the make test commands here. So let's go ahead and take a look at this. Okay, so it sets up Python 3.8, installs the dependencies, and we can kind of watch this thing. We can look at the output of any of these jobs by typically refreshing it here. There we go. Install the dependencies, linting it. Looks like everything's done, right? So it was able to successfully run through, test our code. In each one of these, I can actually go through and look at the output, right? And we see all of the different tests that have actually been passed. Now, let me show you what all of this code does. So if we go back to this repository here, what I can do is look at GitHub workflows, and in particular, the Python application test with GitHub Actions. We say on push events, I want to run this in Ubuntu latest, and I want to set up Python 3.8. And here's actually the Python version, which is 3.8. And then I just go through the steps that I set up in my makefile. I install the software, I lint the code, which we didn't go into. I'll go through in a second. And then in addition, I will make the test, and then I'll do make format. So if I go through here and do the same things, let's go ahead and do those. So we've already done, we did make install, and that one's pretty easy. And let's just look at all the steps in the makefile. There's make test, which we have done multiple times. There we go. And we also do make lint. And if all the lint does is it looks for the files and it lints them. So we can say make lint. Now we probably could add some other files here. So we know that there's hello CLI as well. So let's go ahead and lint that one. And there we go. That one passes lint as well. And in a nutshell, what's nice about this is that I can have this repeatable automated process that tests everything. So we actually have a very structured project here that allows us to kind of expand and build more complex command line tools. And it all started again with this function. The other thing we can do is GitHub Actions. If I click on this link here and you click on this 3 dots, you can say create status badge. And I also can take this and put this into the README file, which is not a bad idea, so that we can see what the status is of the build. So I think this is a nice feature of GitHub Actions here. And let's go ahead and do that. Let's just throw this up there. There we go. And now we've got a build process as well. Now if I go back to this location, I can say get pull and get the latest changes. And if I say get status, notice I made a small change to the make file. So I'll go ahead and add this. And also notice that this is a virtual environment here. And so what I'm going to do is I'm going to add that to my git ignore right here. And I'm just going to say, what was that called again? It was called Python 3.8 virtual environment. Let's just get rid of this and add it to our git ignore so I don't accidentally check it in. There we go. And if I say get status, there we go. We can say get add.getIgnore. Adding ignore. Perfect. Okay, so we've got pretty much a full working command line tool, and we started with something really, really tiny. Now, what else can we build that would be, more useful? Well, let's try to build some more command line tools. So let's look at this one here, which is another one I've got in here, which is called Computer Vision CLI. So what this one does is allows us to pass in the name of a bucket in Amazon S3 and actually do computer vision based on what's in that bucket. And in particular, it has a labels function that will allow us to detect labels. So in order to test this, I'm going to switch environments. I'm going to swap over to AWS here, and I'm going to go to something called Cloud9. I'll make this a little bit bigger. So let's go to Cloud9. And Cloud9 is really the Amazon equivalent to this. And I can go ahead and just open up any environment inside of here. And what this will do is allow me to natively connect to Amazon so that when I'm doing API calls, things are a lot simpler. Now, if I went to Amazon recognition, and I think I have a picture somewhere here on my desktop. If I don't, I can just download it. So I'm gonna go through and say like Google image search here, and I'll just type in like a lion, right? So we'll just go through here and say a lion. Great, there's a picture of a lion. I don't know, this one looks good. I'll just go ahead and save that. And we'll call this lion, and then maybe like a tiger next. Get a tiger here, great, here's a tiger. We'll go ahead and save those. So I'm gonna grab these 2 images, and then I'm gonna go not only to this Cloud9 environment, which we'll get into in a second, but first I'll show the what you can do with the services in AWS. So they have something called recognition, which allows us to search and analyze things. And in particular, we've got object and scene detection. So if I go ahead and I throw in here, I would just throw this into drag and drop this lion. You'll notice that it finds that it's a mammal. It does wildlife as another label, animal is a label, lion is a label. If I throw in a tiger, it goes through here, same thing, really similar. So that's really the use case here, is that we have a pre-trained computer vision model that does labels. And so I want to maybe operationalize this and use this. Well, how could I do this? Well, what we could do is build out something that will allow us to do this programmatically. And so in order to do that, I'm going to check out this project, this function bike rider, inside of this Cloud9 environment and start to build this out. So I'm going to click on code here, and I'm going to go to this repo and copy it, and then go back into this environment. And I'm going to say git clone, like this, and clone this. Notice that you will have to set up SSH keys if you haven't set that up. And I have, basically in a nutshell, we'll just briefly say what that is for SSH keys, you would just need to type in SSH keygen -t RSA, go through, generate the key, take the public key and put it into GitHub. I've already done this previously, so I won't need to do it. All I need to do is do git clone. Once I do that, it puts it into this environment, which has also got great Python support. And now I can look at this CLI tool here, right? Now, what I'm going to do here is actually restructure this a little bit, because the logic is in this labels function, and I want to test out the labels function independently. And I guess, basically it's already kind of pre-embedded into this command line tool. So what we could do is we could just take this function here and we could just put this into another file real quick. So let's cd into here. I'm going to create a virtual environment. We'll do this function bike rider, and let's source it. Okay, now that I've got this, we can see that we're using this virtual environment, Python 3.6. Okay, and what I can do here is make another file, and we'll just call this label labeler. How about that? Or we'll just say labels. Labels sounds good. Labels.py. And if I double click on this thing, we can paste this in. And this says this takes an S3 bucket and an image name. So this is the bucket name and this is the image name. So in order to get this thing working, I will have to import Boto3. So we'll go through here and we'll say import Boto3 like this. And I also will need to do something with this code. So I'm going to need a bucket and then a name of an image. So in order to do that, let's go over to Amazon S3 here, and let's create a bucket. If I don't have one handy, let's go to, I probably have one that I could use, but let's see if I can create another bucket, if they'll let me. We'll call this function bike rider. And we'll go ahead and create this. Uh-oh, I've created too many buckets. I knew I was going to get trouble with that. So I'll just delete some bucket, and I'll do that. Okay, doesn't like that one. Let's delete census demo. If it doesn't, I'll just reuse a different bucket. Yeah, I got too many buckets in my project. I can just put it into, here we go, Alfredo Noah. This is a good one. I don't think there's anything in here. Or I'll delete these. We'll just delete those things. And I can just permanently delete this. Okay. So we'll use this Alfredo Noah bucket. in our code. And what I'm going to do is I'm going to drop in a picture of the lion inside of here, just like that. There we go. So we've got this picture inside. It's called lion.jpg. Now, how do I now get my code working with this? Well, what I would need to do is, in my opinion, the best way to do this would be to use IPython again to play around with this. So if I go here, I can actually say from labels import labels. We didn't install Boto 3. So that's easy enough to fix. What I can do is I can go back to my requirements file here and notice that I didn't do a make install. So that's one problem. So let's go ahead and do a make install. And this should put everything inside my project. Command exit. Not sure. Oh, I know what the problem is. This one doesn't. I think it doesn't like this library, which we can get rid of. The black library, I believe, might be the issue. Let's try it again. Yeah, that's a formatting library that likes the newest versions of Python. So what I'm going to do is go to my makefile here as well, and maybe just get rid of the format step here. We can just get rid of this step. We don't need it. It's a nice to have. And then I also can go to GitHub Actions here, and we can change that out, right? So this is common too. Is like these are things where you can. Nothing's precious. Whatever it is you're doing, you can tweak it and change it. Because we have all this protection and tests and everything, it's easy to verify everything works. So if I say make test, for example, everything works now. Make lint, right? So I have a good safety mechanism here to make these kind of changes. So what I'm going to do again is I'm going to test that out. So we'll go through here and we'll say IPython, and I will say from labels, import labels. And I believe that there's an issue here in that it's using the wrong, not sure why it's not recognizing Boto 3 here. There could just be sometimes IPython has weird issues in these environments. And so what I can do is just use the regular Python shell, which is fine. And I can just say from labels, import labels, and then I can just test this out. So we know it's going to take a bucket and it's going to take a name. And so I can just say bucket is equal to, and we know that'll be Alfredo Noah was the name of the bucket. And then the name would be equal to lion. Let's go double check here. It would be lion.jpg. So lion.jpg. Okay, and then I just need to pass in this function. So we'll say results is equal to labels and bucket and name. And let's see what happens. There we go. It looks like there is some kind of an issue here. Maybe I misspelled the name of the bucket. Potentially, not sure why that is got an issue. Let's go ahead and try this out. Actually, to make it even simpler, what I can do is just run this as a script, right? This is probably the easiest way to do it, which would be labels and put in Alfredo Noah. And then put in lion.jpg. There we go. And if I run this, we can get these labels. So there could be some weird issue here. There's some kind of a bug here, and I'm not sure if it's that I need to put in. Is it that? I don't think you needed to do that, but yeah, I thought you just needed to put in this particular name. Unable to get object metadata from S3 or access permissions. Yes, something's weird about this in particular. Not sure. Oh, because I never uploaded it. There we go. That I was like, something doesn't seem right here. So here we go. That now it's able to detect it and offend. This is the image, and so what I could do is I could just say print labels here and run this. There we go. So in this case, it doesn't seem like it found any labels, which is kind of weird actually. And so what we could do is just tweak this a little bit, and let's look at the original script and see what it does. So in this case, it says for label and labels. It looks like this should work though. So what I'm going to do is I've tested out the majority of this function here. Let's go ahead and like convert over to the command line tool version. So if I go through here and I say, let's do the same thing I did before, is we have this shebang line. So I can test out this thing, which is CV CLI. It looks like it works. So it's going to ask me for the bucket, and we'll say Alfredo Noah. And then the name of the image, again, is lion.jpg. And it was able to give me these labels. So it needed to iterate over that object here. So we can see that it found the name of the lion. The name was lion. The animal was mammal. Now, let me show you how else we could use something like this as well. One of the things that we could do is one of the cool things about this particular Cloud9 environment is you can copy things into an S3 bucket. So let's say that I want to take this tiger picture, and let's just say that I put it into here. I can just drop it. I can actually just throw this here like this, right into this machine. Notice that it's up there. So if I just go up one level, you should see this tiger. So what I can do is I can just copy into that directory this image. So I can say AWS S3 CP and copy this into this bucket, Alfredo Noah, like this, right? So copy this in there so then I can run my command line tool to detect it. And this, I think, would be a very common workflow that you would probably do if you were building, command line tools for doing computer vision. There we go. We uploaded it. Let's go back. Let's double check that it exists. If I refresh here, there should be a tiger as well. And there is, I believe. Let's see. There we go. There's a lion and a tiger. So now let's run this code again, the one that goes through and it finds the bucket, and then it does our click command line tool here. And we'll say, let's go into function bike rider, and let's run it. Remember again, it says it accepts a bucket and a name, so we can just pass it in this time. So I can say bucket is equal to Alfredo Noah, and then the name is equal to, in this case, tiger.jpg. There we go. And now this one, let's look at the results of it, and we can see that it found the label tiger with 99% confidence. Also, it's confident that it's an animal, it's a mammal, wildlife. So we use the same pattern again. The same pattern here is that you build out, kind of test out the function, get it working, then put it into a command line tool, and then start to build more complex things. And in particular, here, I can actually just get rid of that the labels file here. I was just using that temporarily, and we can say get status. We can add in these changes, which really didn't change anything in a material way, but let's go ahead and do these. This just removed the black function, get add requirements. So why would we care about this? You know, what is the real problem that this is solving? Adding changes is that a lot of times a command line tool is the start of building something more complex, and in particular, the more complex piece could be, not only do I want to build a command line tool for this, but maybe I also want to do a trigger where I automatically detect things based on, you know, a trigger that I use with Aws Lambda. So in particular, one of the things that we can do is if I go, let's open up another terminal here, is I could keep going down this road and go to Aws Lambda. And what Aws Lambda does, which is very related to the kind of things we do, is it allows me to build these kind of functions as well. So let's go ahead and say, you know, Marco 12.8, and we'll change this to Python 3.8. And for, yeah, let's just make this real quick. So the core concept is very similar to what we were just doing. Again, it's just a function, it has some input, it does some stuff, and it returns back. So I could actually just copy here the other file that I had, which is this one, hello. We could basically build something like this, right? And so if I go back here, I can go to Lambda, and I can go to the code itself, and I can just get rid of this. I don't need this, and I can just go through here and just process the event. The event is what gets passed into this function, and the way this works is I can say if event is equal to, if event name, let's just pass in a name here, is equal to Marco, return back Polo, or just return back no, like this. So literally the same thing that other command line tool did. We deploy it, I test it, I can do the same thing. I can just say, you know, name is Marco, and we'll do Marco here. Invoke it. There we go. And look, we see that it was able to successfully execute Polo, right? So same kind of concept. So why did I bring this up? Is that we can do the same thing we did now with the computer vision technique as well. So let's go ahead and build one of those out real quick. If I say create function, I can build out a computer vision function. So we'll just call this computer vision 12.8, and go through here and just say Python 3.8. Sure, that works. And then for permissions, I will need to have a role that will let me do privileged API calls. And so I'm going to use one that I've had earlier. Here we go. There's an admin role. And really the only thing I need to do now is just kind of wire together enough code so that I can do the same thing that I did previously. And what I can do here is I have an example of this in a computer vision repo that I believe I can just copy and grab. So I think it is this, not this one. Lambda S3 trigger, I believe, is the one I'm looking for. Yeah, this is what I want. So basically what this code does, and I'll check it into this repo, is it has a label function that does, you know, goes through, finds the labels, and then it has a handler, which again processes this event. And what I do is I say for every record in the event, so every time something happens, like there's some kind of a trigger in S3, it'll go through and it'll run those labels for me. So this is a very common workflow that someone would set up with something like Aws Lambda. So to do that, I'm going to go here and I'm just going to copy this in, and we'll put this into our repo. So go back to this cloud project first to just make sure that it's in here. We'll just say touch S3 trigger Lambda. And all this, I'm not going to directly use it this way. I'm just going to put it in here so that we have access to it. We'll say git status, git add S3. There we go. And commit this, adding S3 Lambda trigger. So again, the advantage of building that command line tool first is I got it working, and it's pretty simple to test out that it works, and it reduces a whole bunch of like cognitive load for me to now build this Lambda. To build the Lambda now, much simpler. We just go here and I paste this in here, and notice again, this is the part that does what I was doing before, and then this is the particular piece this is the Lambda handler, right? That goes through and it all it does is print out the labels. It could do more complex things if necessary. So if I go through here and I do this, we can say deploy. Now to run it, we'll need to do a couple things. First, let's clean out the bucket so that we can verify that what we're doing is actually working. So first, let's just delete these things inside of here. So we got this bucket done. And then the next thing that I'm going to do is I'm going to go back to this code section here, and I'm going to do a trigger setup. So how do I set up a trigger? Well, the way you do this is I'm going to say latest configuration and go to triggers. And under trigger, I'll say add trigger. And all the trigger does is it's who gets to call it or who gets to invoke this function. And if I go down here, I can find an S3 event. There it is, S3 event. And then I just need to tell it where to accept the trigger. In this case, the trigger will be this bucket called Alfredo Noah. And I'll say every time I put something in there, go ahead and grab it out and do something with that event. And then we'll go ahead and say, add this. There we go. Perfect. So we've got this thing enabled. There we go. This looks like it's ready to go. So really we're ready to test this thing out. So how do I test it out? It's actually that simple. If I go here, I can just grab this tiger and I'm going to upload it. There we go. And we'll say upload. This should immediately trigger this function. And so if we go back here and I say monitor, I can see the logs here. And this will show me all of the logs that this thing does. There's a couple of ways to look at this. I'm going to look at it in CloudWatch logs. And once it's working, we should see a print statement. There we go. We can say, this is my bucket, Alfredo Noah. This is my key, which is a tiger. And it went through and it found out all that information. So now we've got actually a event that just sits there and it waits for us to tell it to do work, which is even more useful in some cases than that command line tool. And in particular, we know that it's only doing the tiger, but let's add the lion. Let's add this lion in here, which is X. Let's go back to this bucket and let's upload another. Let's add the lion. Here we go. We'll say upload, and it should be instantaneous. If I go back to this CloudWatch logs here, we should see that here's the lion. Let's refresh. Or here's the lion. There we go. There's a lion, and I found these labels. So this is now generically going to work with any kind of thing that I put in there, that it'll detect whatever label that I've got set up. So this is really almost production ready for maybe a company that wanted to build a computer vision pipeline that labels the data before it goes into, let's say, another part of a machine learning system.